Before we think about linear search and binary search, let's think about what is search itself first. What is search itself? So when you do search, you need first the data structure or data set. So for example, like an array, we're going to learn linked list soon, like a list, array list, set, map, stack. There are so many data structures in Java. Then when you have like a data set, if you need to find a target value, we call that process as search. So there are two popular ways. One is linear search. Linear search means a line up in one line and you are going to check one by one. So in the linear search, most popular code is look like in the array. With the for loop, you are going to start from the very first item, the very first index number. So let's think about we are going to have an array. Then until the end of the data set, data structure. Then you are going to check if my current one is a target or not. If it's a target, found. If it's not target, you're going to keep checking. So that is linear search. How about the binary search? For the binary search, there's a precondition. Binary search can be used only for sorted data. Data must be sorted first. Then, if you use a binary search, you are going to find very quickly when you find an item. So actually, if I say the big O efficiency first, the linear search big O efficiency is big O n. Binary search big O efficiency is big O log n. There is just one sample. How about here, my target is quiet. How can I do the binary search? This is first is sorted because uppercase is smaller than lowercase. If I check from the first or last, it takes so long. So we are going to do some calculation. Find the mid. Mid position will be first plus last divided by 2. In this case, if I put the index number, first plus last divided by 2 will be 5. So 1, 2, 3, 4, 5. So this one is mid. 8, 9, 10. So start from mid, compare. So I'm going to compare with this data, current data, what mid is pointing, then compare with my target. My target is quiet, that means my target is bigger. If target is found, that is found. Then if target is bigger, now I need to research. But when I research, what I'm going to do is, now it guarantees, if the target is bigger, it guarantees my target is not before mid. That means discard before mid. So you will never check before mid. Each time you are going to discard half of the data. That's why binary search is big O log n. Each time you are not going to check half. Each time it becomes half size to check. Then for the second check, now I have to change my first, move my first pointer to the mid plus 1. So if target is bigger, I'm going to change first as mid plus 1. That means if target is smaller, I'm going to move last to the mid minus 1. Because I changed the first, now we are going to calculate second mid. So calculation is the same. First plus last divided by 2. Now 6 plus 11, that is 17 divided by 2, that is 8. Now mid is pointing index 8. And compare, I found. So by just doing the 2 times comparison, I found my target. How about if I use the linear search? 0, 1, 2, 3, 4, 5, 6, 7, 8. It should have 9 times comparison. So In the most cases, binary search is much faster, but one restriction, this is only for stored data. Now you are going to write down the code for the binary search and linear search. Linear search is easy. You can just use a for loop, like iterative way. You are going to just do it. And in the binary search, we want to do recursive way. So helper is a recursive helper method, binary helper. So each time you are going to change one of the variable, one of the argument, and send it. So how my binary helper will work? We're going to have some basic cases. First basic case first. First basic case means you couldn't find. How do I know if first and last swap? That means if first is bigger than last, then say you couldn't find it. So if first is bigger than last, that means you passed. It's a false base case. How about the true base case? That means you found the goal. True base case is you found the target. If you see here, when compared to method returns 0, then there will be two recursive cases. You need to look at the left half or right half. So two recursive case. You can think about those two recursive cases. When the target is bigger, you are going to look at only right half. If target is smaller, you are going to look at just the left half. So that is a binary search, how to write the code. Then there is a sample run, so you can look at this sample run.